Let us take the law of gravitation as our standard example. If I have a sun and a planet that I started off in some direction going around to here, and then take a moving picture of this, say it gets to here. Now take a moving picture of this backwards. Take a moving picture of it, and run the movie backwards and look at it. What happens? Planet goes around the sun in an ellipse. The speed of this way, of course. Starts here, goes to here, keeps on going around. Goes in an ellipse. The speed of the planet is such that the area swept out by the radius is always the same in equal time. Just does exactly the way it ought to do. It's perfectly satisfactory. It cannot be distinguished from the one going the other way. So the law of gravitation is of such a kind that it doesn't make any difference. If you show the phenomenon running, any phenomenon involving just gravitation running backwards on a film, it'll look perfectly satisfactory. Put it precisely more this way. If at a given instant the particle are moving this way, if all the particles in a more complicated situation would have every one of their speeds reversed suddenly, then the thing will just unwind through all the things that it wound up into. That is, if you have a lot of particles doing this, then you suddenly reverse the speeds, they will completely undo what they did before. Now this is in the laws of gravitation, which say that the velocity changes as a result of the forces and so on. If I reverse the time, the forces are not changed, and so the changes in velocity are not altered at corresponding distances. And so each velocity then has its succession of alterations made in exactly the reverse way that they were made when it went out before, and it's easy to prove that the law of gravitation is time reversible.